lot of area, and when you have the bolt coming through it, the bolt section area is very small. You know, if I'm taking about 1.5 inch bolt, for example, as opposed to these big flanges coming together. When it's all preloaded, when things don't move, I have less stress amplitude in the bolt than if it was loose. It's almost half an hour to go through the calculation for that, but there's a very detailed calculation I could show you, essentially explaining a factor of stiffness of 7 between the little round bar that's our threaded rod and the whole assembly here. If you want to think about it in a simple way, what I suggest is, if you have this tight connection that I've been trying to convince you was better, you get the load to go across this whole area here, all the way from one nut to the other. If this isn't tight, and all I have is the bolt, and I have the load going in that portion, and there is no contact on top and above, well, yeah, this is going to stretch a whole lot more, because you have less material. So think about it this way. It's all tight. It's preloaded. It stays together. The contact stays here. The load, the line of load from pressure variations, external load, you name it, will go all the way across the full assembly. If it's disconnected a little bit, it will go through the fastener. This is going to be a much higher stress level, and therefore it will create more fatigue. So with fasteners, we really care about the initial yield strength, because that's what allows us to preload them without damaging the threads, without breaking them. So it's the reason why SAE has come up with these very specific requirements, and everyone uses them. And if you go to pre-stressed concrete cylinders and other structures that use steel, very, very high strength steel, it's the same story. They tell you very precisely how to do it, because the consequences of a small variation are very important. The higher your performance criteria, the more likely you are to worry about variations. This is a project, it's very different. I worked in New York, so Central Park is this week, and it was for the inauguration of someone who, Mr. McDouglas, I think, made a very good contribution to the history of America. And anyway, the structure I was working on is this big tunnel here that was a big wall fountain. Very large pumping system to get the water to distribute along little holes here and coming out very nicely. And I actually have a video at some point it was working. The problem there is you're dealing with artists and general engineers, and they care about aesthetic more than they care about things not breaking. So the mistake they did there, essentially to focus on the chemistry of the bronze. These panels were bronze. Very nice. But started cracking. Big time. This is a project at a company I used to work in. I don't have the file, but there was cracks from here going all the way to the middle of some panels. It didn't look good, and they had cracks also. These were ports for light systems. They're supposed to be waterproof. It was leaking. All sort of brazing and welding issues. The bottom line was the bronze panels, as they were built, were brittle. They couldn't take 0.5% strain. That's nothing. Now, were they required to be deformable according to the engineer of record? Yes. Now, did he say so? No. All he asked for is a Copper Development Association number, and I don't remember which one it was. So It started with a C here, it's got 3 or 5 digits. And if you want to know the chemistry that he asked for, just on their website, you have to go to the section on resources here. They have a section on specifications, okay? But where I am here, I went to resources and alloy properties and use. These are not minimum requirements. If you go through all the database, it just says, well, maybe you'll get this. They call it typical values. With a casting, a typical value doesn't mean much because it will depend on how you cast it. Are you going to control the oxidation? Are you going to be doing investment casting? What exactly are you doing? Sand casting? Are we looking at the core? Are we looking at the surface? You know, what are we doing? What's our superheat? Everything will matter. Anyway, so it was a really sad story because when it's all done, with a lot of times you can't just go back and do a heat treatment. If the casting structure is such that there's enough segregation between the different alloying element, you won't be able to blend it all together. There's no magic, black magic, like we have with steel. You can deal with a lot of things. You can put it into solution and quench it again and do what you want. In this particular case, you have to melt it again. But the molds they had were not reusable molds, they were one-time use. So the only viable solution that I could offer to them was to isolate every single panel as a piece with expansion joints so there's no stress on it. Because the way they had it, it was brazed. This panel was connected to this one, and therefore as a large structure with seasonal variation, you'll have a lot of mechanical load. So it's okay to have a structure that doesn't have ductility if it's only standing there by itself. But if you're going to go through settlement, seasonal temperature variation, they had a lot of issues. And there's this water on top, so it had to be sealed. So I think our recommendation, I was working with a bunch of structural engineers, and some of them would just redo it, but my take on it was we could take it down and re-engineer the joints and be able to use those panels. But as is, it was just, you know, a big mistake altogether, and they were missing deadlines for inauguration and, you know, everything that comes together with a project. So I hope I convince you the different level of specification, the material composition, the performance, the process. I showed it mostly with the bolts. Material installation, we don't have time. I'll cover that briefly tomorrow. And I hope you have a great day. Any questions? We don't have it. Yes?
Whatever happened to those straps that went up to the letters?
Grading. Yeah. There was no way to try to peel the weld that out. And brazing was very difficult in terms of maintaining that finish. A lot of